Hello dear students, welcome to Teja my YouTube channel. In this video I am going to give you the list of all the formulae from the chapter electric charges and fields. See dear students, this chapter is from 2nd PUC physics syllabus. So this is the first chapter. So let us start with the first formula. So in properties of charges you have studied this formula, that is quantization of charge. Quantization of charge. So it is given by Q is equal to N into E, or you can also write plus or minus N into E, where Q is charge, N is an integer, and E is basic fundamental charge, and its value is given by if it is electron negative, if it is proton it is positive. Okay, now let me write the value: 1.6 into 10 to the power minus 19 coulomb. This is the first formula. Next we have the second formula, that is Coulombs Force. Let me write here. Coulombs law of electrostatics. Okay, in this we have the force between electrostatic force of attraction or repulsion between any two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them, and it is given by 1 over 4 pi epsilon naught q1 q2 by r square. This is when we consider the charges in air. Here this is in air or vacuum. See, you must have already completed this chapter, otherwise theory concepts clear ಆಗಿದ್ರೆ ಮಾತ್ರ ಈ ಫಾರ್ಮುಲಾ ಲಿಸ್ಟ್ ಬರ್ಕೋಬೇಕಾಗುತ್ತೆ. First be clear with the concept that you have already learnt in this chapter, so that you can understand this formula easily. Next, if in case a dielectric medium is introduced, so in a given medium, 1 over 4 pi epsilon naught q1 q2 by r square into k will come here. You can write k or epsilon r, both are same. So relative permittivity or dielectric constant. This is another formula. This is the force between two charges. It may be positive, attractive or repulsive based on the polarity of the charges. So this is in given medium. Okay, next, that is dielectric constant. What is the expression for dielectric constant? Dielectric constant. So it is K is equal to Coulombs force in air divided by Coulombs force in given medium, or you can also write like this: see, epsilon naught into epsilon r is equal to epsilon. Relative permeability is epsilon r, absolute permittivity is epsilon naught. This is permittivity of the given medium. Okay, so this is called K, means this will come to the denominator, so that we can also write epsilon divided by epsilon naught. This is the force between two bodies in air or vacuum. So F naught by Fm, that is equal to epsilon by epsilon naught. There are two formulae for this particular concept, that is dielectric constant. Okay, next we'll move on to next formula. That is electric dipole concept. Electric dipole. So what is an electric dipole? See, electric dipole is a pair of equal and opposite charges separated by small distance. So let me draw the diagram for that. Here we have positive charge, here we have negative charge, plus q charge minus q charge, separated by small distance 2a. Now electric dipole moment formula is there. Electric dipole moment is represented by P, that is equal to 2aq, isn't it? You must have already studied this concept, 2aq, and if you write this in vector form, you get this. P is equal to 2aq. So electric dipole moment is a vector quantity. Then what is the direction? Vector means it is having both direction and magnitude. So direction of electric dipole moment is always from minus charge to plus charge. Now next thing, it is the net force and torque acting on dipole placed in electric field. Means, so let us discuss about electric field here. Electric field. What is the formula for electric field? E is equal to force per unit positive charge. So this is one formula. Second one is E is equal to 1 over 4 by epsilon naught q by r square. Q by r square. Next, sir, what is the value of 1 by 4 by epsilon naught? Here also I have not given, right? Let me give the value of 1 divided by 4 by epsilon naught value is 9 into 10 to the power 9 Newton meter square per Coulomb square. Per Coulomb square means minus 2. Now let us move on to next concept, that is net force and torque acting on electric dipole placed in uniform electric field. Uniform electric field, that is given by, see, the net force acting on the dipole placed in uniform electric field is 0. This we can expect for 1 mark. Then torque acting on the dipole is given by P sin theta. This I have already derived in the previous videos. Please do watch it. In vector form, it is given by P cross E. P cross E. Okay, next we will move on to electric flux formula. 7th one, it is electric flux. Electric flux. Okay, so we can represent this in different ways, but I will write the easiest one. Electric flux is given by E into A into cos theta, where phi is a scalar quantity, do remember that, and in scalar product you can write this as E dot A So this is scalar product, and electric flux is, what is this? Scalar quantity. Okay, so this is vector, this is vector, but phi is scalar quantity. That's why we have written scalar product here. See, for torque it is vector product, so that's why cross product is there. Okay, so this is also a vector quantity, so cross product. Then there is one more formula for electric flux, that is Gauss law. Okay, so it's given by phi is equal to q by epsilon naught, isn't it? Have you studied it or not in Gauss law? Net electric flux, total flux through a closed surface, is equal to 1 by epsilon naught times the net charge enclosed by it. Okay, na? These two are the two formulae for electric flux. Next, linear charge density, surface charge density, and volume charge density. Linear charge density is given by charge per unit length, or you can also write like this, dq by dl. This is linear charge density. Okay, na? Next, second one, surface charge density is given by charge per unit area, or you can also like this, charge per unit area. For small charge is surface charge density or volume charge density. Area charge density, surface charge density. Next, last one, it is volume charge density, charge per unit volume, dq by dv, volume charge density, volume charge density. Okay, na? So next, we move on to the ninth formula, that is electric field due to uniformly charged thin and straight wire. There is a derivation. This comes under applications of Gauss law, like you consider a Gaussian surface here, due to which at this particular point what is the electric field at a radial distance r, where linear charge density is lambda. Then this electric field is given by E is equal to lambda divided by 2 pi r epsilon naught. Okay, this is the formula. Next, if you consider electric field due to thin uniformly charged infinite plane sheet, so here also we'll have to consider the Gaussian surface on both sides. Like this, I have drawn one diagram and found the expression for electric field, that is given by E is equal to, in vector form or scalar form, you can write sigma by 2 epsilon naught. And due to electric uniformly charged thin spherical shell, you will get E is equal to 1 over 4 pi epsilon naught q by r. This formula also you will get. So these are the different formulae for what is this, the chapter electric charges and fields. Okay, I hope I have covered all the formulae from this chapter. If you feel that if some formulae are missing from this particular list, you can text in the comment section, so we'll try to add them in the future videos. Okay, so all the best. Tomorrow you're getting the results, so we'll meet you in the next video.